Okay, these experiments, three experiments, A, B, and C, are carried out to investigate some of the factors that affect a rate of decomposition of hydrogen peroxide, which is H2O2, and it starts off as a liquid, as we see. And then they say the balanced equation for the reaction is 2H2O2, and then this gives 2 of water molecules, also liquid, plus hydrogen gas. What am I doing today? Plus oxygen gas. And then they say identical samples of hydrogen peroxide are used in each experiment. And this is what you usually expect for rate of reaction. They'll use the same reaction, maybe 2 or 3 times, but they'll change at least one thing. And that is the factor that we are investigating. See, maybe this time we're investigating 2 factors or maybe a few, but there's always this factor that we're investigating in the rate of reaction. Okay, so the condition that we used are summarized below. In experiment 1 or experiment A, we used 25 degrees Celsius and we didn't add any catalyst to the reaction. Experiment B, we used 25 degrees Celsius again, but this time we added a catalyst. Experiment C, 35, and we didn't use a catalyst. So let's see what we get. Question 5.1, in which experiment A or B is the reaction rate higher? Use the collision theory to explain the answer. Okay, just looking at A and B, first of all, which factor are we focusing on?
Temperature.
Temperature. Okay, Donald, what do you think? Which factor are we focusing on 5.1?
I think it's temperature.
Temperature. Okay. Why temperature? Just briefly.
Wait. Because I'm thinking my answer for 5.1. Because, can I say my answer for 5.1?
Yeah, you can.
Because I'm thinking the answer is B because of the presence of the catalyst, since it creates an alternate. I forgot the whole process. Alternate activation energy, something like that. Then also more effective collision.
Yeah, it's always the same kind of what can I say? Yeah, the same kind of words, but I did send the notes, so just make sure that even if it's not now, you just make sure that you do remember what they say. But once again, the first point that I wanted to make here is which factor are we actually investigating? And you guys said temperature, but look at this, temperature is constant for these 2 experiments. So the thing that we are investigating is the one that we are changing to see what's going to happen if I change it, right? Yeah, so which one is it?
Catalyst.
A catalyst. If I keep the temperature constant, then in one experiment I add a catalyst, in another I don't. It means I'm investigating what changes will result due to adding a catalyst. So the factor that we're investigating is a catalyst, and the correct answer for this is B, because if we have a catalyst, then automatically the reaction rate should be faster, but now we have to give reasons for that answer, and you have to give those reasons looking at the what we say or the effects that are brought about by a catalyst. And once again, those answers are there very nicely for you. I'll send you the PDF if you don't have it already in the groups, so that's okay. But it's important that you understand what they're looking for, and that in this case it's a catalyst. Okay, let's look at 5.2, the Maxwell-Boltzmann distribution curves. You have to remember those as well. Not a lot of work on those. Also, they are included in that PDF with a summary. you just need to understand three Maxwell-Boltzmann distribution curves. So in this case, we're given x and y for two of the above experiments. So x can represent A, B, or C. Y can also represent A, B, or C. Then the question is identify the curve x or y that represents experiment C. So looking at experiment C, which curve x or y is giving that experiment?
Why? Because it has higher temperature.
Yes, it's y because it has higher temperature. And a lot of people can get this one wrong. It was 2 marks. And if you look at the notes for Maxwell-Boltzmann distribution, what we say is that if we increase the temperature, then the number of molecules you see here on the y-axis, the number of molecules that will have higher kinetic energy are going to increase as well. So what does this diagram actually tell us? There is a line here. In this case, they didn't show it. This line is called activation energy line. And in chemistry, we try to make all the reactions or the reactants have more kinetic energy than the activation energy that is required. So if I increase the temperature, look at curve Y, you can see that more particles are going to be on the right side of the EA line. That means the temperature there is higher. Okay, but if you look at experiment or if you look at curve X, you can see that we have more particles on the left, which means that is not good. We want more particles to be on the right for effective reaction or effective collisions. So Y is the correct answer because Y represents a higher temperature. And only experiment C has a higher temperature. So I feel like that one is simple if you understand the Maxwell-Boltzmann distribution curves. 5.3, moving on. The volume of oxygen gas, O2, produced in experiment B. So you need to just quickly check what experiment B is about, and it's just an experiment that is happening at a temperature of 25 degrees Celsius with a catalyst. Then they say during the first 3.6 seconds, produced in the experiment B during the first 3.6 seconds is collected in a syringe as shown below. Okay, so after 3.6 seconds, we collect this much volume of oxygen, and what we collect is inside this closed part of the syringe. 5.3.1 says write down the volume of O2 collected in the syringe. So what is the volume that we read there?
We have to find the difference.
Okay, everyone else, you can feel free also to interact. It's for everyone. So we have to find the difference of what?
We have to find the difference between the 640 and the 480. Well, how much do we add to get this?
Yeah, so what she's saying basically is because the syringe is stopped right between 480 and 640, the answer is there. It's like in the middle of those. Anyone else can figure it out the way they can. What I'm thinking is that I just need to find the average of those two numbers, then that's the answer. Or however way your brain is wired, you can use that, but you can see what you're required to do. So 640 plus 480 divided by 2, yes?
60.
600.
Let me check.
Okay.
560. 560.
560. Okay. So 560 cubic centimeters. Or of course you can just find how much you add to 480. then you're supposed to get the same answer, 560. Okay.
Yeah.
Okay, good. 2 marks. They will not mark any method for this kind of question. They'll only mark the final answer because you can use any method you want. So they don't really care about what you do. Okay. So let's look at the next question. It says the balanced equation for the reaction is this. 5.3.2, calculate the mass of water. Okay, we're looking for the mass of water, H2O liquid, that was produced during the first 3.6 seconds. Take the molar gas volume to be 24,000 centimeter cubed per mole at 25 degrees Celsius. Okay, so basically, when you reach a question, usually a calculation question, just try to understand what is about, what they are requiring you to do, what is the method that you need to follow before you even write anything down. Okay, so what do we need here?
We need the mass of water. But we have more concentration. But why is it in centimeters per mole?
Okay,
So does it mean that we're not changing 560?
okay. First of all, is this the units for concentration or no?
DM.
I think concentration is this mole per decimeter cubed or mole per centimeter cubed if you want. So this one though is centimeter cubed per mole.
More.
So maybe one mistake that you could make, very, very dangerous mistake, just be careful of what you're given. In this case, it's a molar gas volume. Do you remember what molar gas volume is?
VM.
Yes, that's your VM. So what is the thought process here? What are we supposed to do to end up with the mass of water?
We always start with the number of moles.
Yes, so you need to find the number of moles. That's your step one. Every time you do stoichiometry, always find the number of moles. So number of moles. So you're doing number of moles of what at the moment?
I think rate of oxygen, I think.
Oxygen. Because if we look at our given data, we see that we only know the volume of oxygen that is produced. We don't know anything else in the information. And we know that in stoichiometry, if I find or if I know the given amount of something, anything in the reaction, and I know that, okay, for a product, that's the amount that I produce, that's good. For a reactant, remember the limiting reagent, we have to use the limiting reagent. But if I know that, then I can find the moles of whatever. It doesn't matter if it's on the reactants or if it's on the products. If I know the number of moles, I can find the number of moles of anything else using the ratios. So in this case, I'm given oxygen. So I can find the number of moles of oxygen. And I need to use this equation because oxygen is a gas and I know the volume of that gas, so I can use this equation. And once again, this equation is used only for gases. Don't even touch it if you don't have a gas. Every time learners are tempted to use that because it's simplistic, but if you don't have a gas, don't ever use that one. It doesn't matter if they mention STP or not, but if you see a gas, you are allowed to use it. Okay. Then once again, if they don't specify which VM to use, then you can go ahead and use the one in the back of the question paper because VM is a constant. So let me show, there it is. But if they specify, then you can use the one at the back. Okay, in this case they specified, and guys, they gave the units in terms of cubic centimeters. Now look at this. We can stick with those centimeters because we also have the volume in centimeters, or to be safe, you can convert everything to decimeters, everything to be in terms of decimeters. But in this case, it's fine. I'll just substitute as cubic centimeters as long as the units cancel. And I'll show you that they do cancel. So 560 cubic centimeter divided by 24,000 cubic centimeters per mole. So I can cancel the centimeter cubed and centimeter cubed, and I'm left with 1 over per mole, which just becomes per mole. So what is 560 divided by 24,000?
0.02.
0.02. And the unit is moles. But what I'll advise you, to avoid mistakes, just convert everything to decimeter cubed, and you just need to divide everything by 1,000. Divide that one by 1,000, you get 0.56 decimeter cubed. Divide the 24,000 that they gave you by 1,000, and you're gonna get 24 decimeter cubed per mole. Okay, cool. Then now that we know the number of moles of oxygen that was produced, and I'll say when you find the number of moles, do specify in a bracket what that is for. This is for oxygen, so write N into bracket oxygen, because if you end up finding a couple of answers for moles, then the marker might get confused. Remember, you're getting marked by someone you don't even know, so make sure that you actually write things nicely. This way, the marker can understand that I'm actually finding the number of moles of oxygen, so they don't need to guess or waste time. Then I can go straight into the ratios. I'm looking for the mass of water, so I need to compare water to oxygen. So water is to oxygen. That's how we do ratios. Then I go to the coefficients, 2:1. Then I know the moles for oxygen is 0.02. Then I can put N or X for water. I'm supposed to cross multiply after that. Then I can see that N multiplies 1 and 2 multiplies 0.02. Therefore, this means the number of moles of water, and you can see I'm specifying in bracket that now I'm working out the number of moles of water is 0.04 mole. Units are important. Okay, then to find the mass, it's simple. We just use that equation that we normally use for mass, or for number of moles and mass, and that is, so this will be your step 3. This was the ratios was your step 2. Your step 3 now is to work out the mass, and this is like the last easiest step, m over m, and I can make mass the subject. This becomes number of moles times molar mass. Substitute in your number of moles. Molar mass for water, I still remember that it's 18. Then what do we get when we multiply that?
0.83.
0.8 grams. Okay.
83.
83. All right. So let me change that. Okay. Any questions on this? It's a classical stoichiometric question. Quite simple according to me.
Yeah.
Yeah. So the way they'll mark, it's important for you guys to know where they'll mark, right? So the way they'll mark this, they'll give you a mark for the formula here at the beginning. Then they'll give you a mark for finding the moles that was produced for oxygen. Then from there, they'll give you a mark for the ratios if you skip the ratio part, then you're going to lose a lot of marks, even if your answer is correct at the end. Then they will give you the final mark for the mass of water. So it could have easily been 5 or 6 marks, but that's good enough for grade 12. Okay, let's see the next part of this question. We need to move quickly a little bit. The graph below, not drawn to scale, is obtained for the mass of oxygen gas produced over time in experiment A. So now we are switching to experiment A, which is the one here on the top. So it's the one where we use 25 degrees Celsius without a catalyst. Okay. Then they give us this graph. This is a classical graph that you always kind of get in rate of reaction. And the graph is quite simple. What it says is that at time 0 seconds, we don't have any oxygen produced because oxygen is a product. Before the reaction stops, no oxygen is present. Then we start to produce oxygen as we go on. After 3 seconds, we already produced 0.4 grams. After 9 seconds, we already produced 0.6 and so on up to a point, and that time value is indicated as just T. We then produce 0.9 grams of oxygen. And it seems like from there on, we stay at 0.9 grams. So what does that mean about this point? What has happened there?
The reaction has completed.
Yes, the reaction has reached completion. So we can say reaction stops or completion. But it's important that you understand what that means. So the mass stays the same value. It means that we are no longer producing, which means our reactant has run out. Okay, use the information in the graph to answer the following questions. Question 5.4.1, write down the rate of production of oxygen gas for the interval 30 seconds to 36 seconds for 1 mark. And you don't need to calculate when they say write down.
Rate of
What is the rate of production of oxygen gas between 30 and 36 seconds?
C. And the reaction has reached completion.
Yes.
So I think the answer is C.
Okay, anyone else? What do you think?
Because
Any other idea? I mean, it could be a reason why it's 0, or you might have a different answer.
M over T.
M over T, okay. Rate of production, it means we are looking for the gradient. Remember, rate of reaction, it's the gradient of that this mass of oxygen graph. So what is the gradient between 30 and 36? The graph is flat, so it means the gradient is 0. You guys already wrote maths, so you understand very well what I'm talking about. Okay, so that's 0, and we have to write the units. If you miss the units, then
Oh,
yeah. So what is the units?
grams per second.
Grams
And
on the Y, second on the X. That's correct. Changing
Mama,
Y
I
over
don't think
changing
I
X.
understand. I'm doubting myself. So if I had units, if that was it, let's use 9 and 20.
Yes.
If we were to find the gradient, we were going to 0.8 minus 0.6 divided by 20 minus 9.
That's correct. So it's just the gradient between 9 and 20. So we're just gonna do the gradient formula, and that's your y 0,8 minus the other coordinate 0,6 for the y, divided by the corresponding coordinate for 0,8 is 20 on the t minus 9 on the t. So you always have grams per second.
And now it's 0 because it was 0 divided by 6.
Correct. So it's 0 because on the y it's 0,9 minus 0,9 for these two coordinates for the y's, divided
Yes.
by 36 minus 30. So on top you get a 0. Division by 0 is 0.
Okay.
Okay, good point. Then let's proceed. You can read the question for me while I erase here.
Will the rate of reaction in the interval 3 seconds to 9 seconds be greater than, smaller than, or equal to the rate of the reaction in the interval 9 seconds to 20 seconds?
Okay, they do like that question, and you shouldn't get it wrong, guys. So you're looking at 3 to 9. So I'm just gonna mark 3 to 9, and I don't know if I can draw a straight line to show the gradient there. Okay, not very easy, but there it is. Then we're also looking at 9 to 20. I'll just use a blue pen to mark that gradient. There it is. Then the question is the 3 to 9 greater than the 9 to 20, or is it smaller or equal? No reason is required.
I don't know if my reason is correct, but I think it's greater because, wait, will the rate of reaction in the 3 to 9, it will be greater because it is steeper. I think.
Yes. So I'm guessing I'm dealing with like mathematicians. Come on, guys. If the gradient is large, then the rate of reaction is large. So we can see that gradient in red is steeper, definitely. So 3 to 9 is definitely faster than 9 to 20. So the answer for this is greater than. If they needed a reason, then you can say the gradient is steeper, and that's it. Okay, very good. The last question on this is the average rate of decomposition of hydrogen peroxide is 2,1 times 10 to the power negative 3 mole per second. Calculate the value of T on this graph. It's a bit of a challenge, 5 marks. You can get it right all the time.
All I know, Guru, we have to find the number of moles first.
Yep, we have to find the number of moles first.
But of what? With hydrogen peroxide H2O2.
Okay, let's look at it this way. Let me just open up space here. Go to draw tab. It's a good question, and it's a good one to actually understand, not to cram, just to understand, so that if you get a different kind of version, then you know how to do it. So in our graph, we are given the rate of production of oxygen. Oxygen is the product. Let me go quickly back to the reaction so that you can see. Oxygen is a product, so products always go up. Hydrogen peroxide is a reactant. Reactants always go down. So in this case, they gave us the rate of decomposition of hydrogen peroxide, but they want us to actually work with the rate of production of oxygen. So if I just on the same graph draw the rate of decomposition of hydrogen peroxide, it will look more like this. So hydrogen peroxide goes down at T, then it's finished. So it's now flat on 0. but that is in terms of moles per second. But if you look at the oxygen one, we are given in terms of grams. So it will be a very good idea to first solve the number of moles of oxygen that is produced on that red dot where the reaction stops. Okay, so then here's what I'll do.
Where decomposition is moles.
Yes,
Okay.
it's given in terms of moles per second. Okay, I want to use this same graph to show this idea. You know, the rate of reaction of production of oxygen is just the gradient from 0 to where the reaction stops, right?
Yes.
So the rate of decomposition of hydrogen peroxide will be from 0 for time to where the reaction stops also for that. So it will be like that. So in other words, if I just do this, let me first find the number of moles of that hydrogen that is produced. So this will be mass over molar mass. Then on the substitution stage, I need to indicate that I'm solving the number of moles of oxygen, because otherwise it doesn't make sense. So I see that the maximum amount is 0.9 that is produced. And what is the molar mass of oxygen?
32.
It's how much?
32. 32.
32. Okay. Then what do we get?
0.028125.
0.08125
28125.
or 0.028125. Let's maybe take 3 decimal places. No, let's take 3 numbers after the comma. 0.028
Yes.
1, right? Okay, mole. So that's the moles of oxygen that is produced. What's interesting, guys, is that the reaction stops at the same time. The hydrogen peroxide will be finished at the same time as the maximum amount of oxygen is produced. So now I can go straight into the ratio. I can go and say, okay, hydrogen peroxide versus oxygen, and the ratio now is, every time in stoichiometry, there's no way you can't do ratios. The ratio is 2:1 from the balanced reaction. If you don't understand, you can ask before we move on. And then I can substitute the number of moles of oxygen to find the amount of hydrogen peroxide at that point. So 0.0281, and I can just put an n there, cross multiply this. Then we see that n of now hydrogen peroxide is equal to 2 times 0.0281. Then what do we get?
0.056.
0.056
2.
2, and that's the moles of hydrogen peroxide that is produced. So now if we know the moles of hydrogen peroxide that is produced, if you quickly draw that graph in your head quickly for hydrogen peroxide, it's gonna look like this. Oh no, wait, this is the actual moles that we started with, and now we are at the moles of 0, but we know the gradient of this now. It's given. They said it's 2, if I remember, 2,1 times 10 to the power -3 mole per second. So I can go and say, okay, to find my T, this is T right here. I can go and say the gradient, I'll just use M, or let me just say rate, is equal to change in the moles of hydrogen peroxide over change in time. Then you can see it's decomposition, so we need a negative there for the rate because it's been finished. 2,1 times 10 to the power negative 3 is equal to change in number of moles. We go from 0,0562 minus 0 divided by time. The corresponding value for 0,0562 is 0 minus the other coordinate for that matches the 0 for y is t. So that's your t. Then you are supposed to solve for that t. Okay, I assume there could be questions on this one because maybe it looks like it's long or something.
Yeah, it will be the reverse of this one. That's how they do things now.
Yeah, so okay, let's see. Then to find your t, just to show you if you are unsure, 0,05962 on top, divide this by, if I just take the t to the other side, then, and I'm gonna leave that negative there where it is, minus 2,1 times 10 to the power negative 3. Then we can find what the time is.
26,76
seconds.
Yes.
Yep, and that's how to solve this one. So once again, if we quickly recap, you needed to find the number of moles. And the reason why we want to convert to moles is because the rate of reaction is given in terms of moles, right? Then after we do that, we can go to the ratio part in order to convert all the information to hydrogen peroxide. Then we can now draw a graph of the decomposition of hydrogen peroxide, and it will show that hydrogen peroxide is going down because it's a reactant. Then we can just find the rate of reaction by substituting that value. I use it as a negative because it's been decomposed, it's going down, right? If you leave it as positive, it's fine, but you're gonna get a negative t value. Then you're just supposed to change it into a positive, and that will work out.
I have a question.
Yes.
Why didn't we use the VM?
Why didn't we use VM?
Oxygen, the gas.
Oh, okay.
They didn't tell us.
Yeah, that's a good question. But remember, these two questions here are very much separate. They don't depend on each other. The one that they gave us the volume, they said it was collected only after 3.6 seconds. But here we move past that 3.6 seconds.
Okay, so when we have volume, that's when we can use the molar volume of a gas. But if you are not given the volume, you don't apply that.
Correct. So yeah, here we were given the mass in grams. That's why we used mass over molar mass. Yeah.
Okay.
It just depends on what you're given. All right. Okay, any more questions from anyone? Don't be scared to ask, guys. If you do have questions, so I'll move on. Then chemical equilibrium, do we go to it or do we skip to like other things first?
Let's browse through that. Let's do question 8.
Question 8. Okay. Question 8 says that a piece of zinc is placed in a test tube. Okay, this is 8.1, and that is not related. It could be sometimes, but usually if the information is labeled as 8.1, it means it's not related to 8.2 if there's nothing on top of 8.1. So just be careful with that, because you might use information given in 8.1 for 8.2 and they are not related, right?
Yeah.
Okay, a piece of zinc is placed in a test tube containing acidified permanganate solution. After some time, it is found that a redox reaction has taken place. Use the standard table of standard reduction potentials to answer the following questions. So once again, you reach a question, you quickly draw a sketch for yourself just to make things easier to understand. So you have a piece of zinc that is now placed in some test tube here, and this test tube contains a solution of permanganate. So there's acidified permanganate. Don't be scared with the part of acidified. It just means that it's gonna have some H pluses inside. Okay. Then let's go to 8.1.1. Use the tables of standard reduction potentials to name or to write down the name or formula of the reducing agent. Okay, fine. We just need to go and check the half reaction for zinc and also the half reaction for permanganate that is being acidified. Just means that will have some H pluses inside the half reaction. So I'll quickly go down to the reduction potentials. Then I'll show what this means. I know you guys like to use 4B, so maybe I'll just use that. But you can use any. And right away, I can see the permanganate half reaction right down there. There it is. So I'll highlight that. Then I'll go to the zinc half reaction as well.
What?
Yes.
Why are we not using the 1 year for 8 plus?
For 8. So say that again. Why are we not using which one?
The 1 year for 8 plus.
Oh, okay. Yeah, I see the one that you're talking about. And that's a good question. Let me highlight it and show the difference. So both of them are acidified. So let's see, which one do we actually choose? It will depend on whether we're given. You can see the one in green there is MnO2. And the one in yellow, it's MnO4. So let's see which one we are given here actually. So let me go. We are given the MnO4 minus. So that is the only reason why we picked that one. Makes sense?
Okay. Yeah.
Okay, nice. Then the zinc, and also we can have questions on the zinc. Let me just highlight the half reaction that includes zinc. And that is where? Help me find it by telling me the numbers here, if you can spot them. Negative 0.76. Oh yes, there it is. Anyone who can spot another zinc half reaction? Anything that includes zinc? Just want to make a point on that. Surely it's not the only one. Let's see.
Please go down.
Yeah, let me go down. Sorry.
I can't see anything.
Oh, so there's only one for zinc. Okay. For most elements there's like 2 or 3, like for copper for instance. But yeah, you're gonna check which one it's actually correct. I hope we get a question like that so that I don't over explain things. So in this case, I'm just gonna take those half reactions that I have, and it goes like this. If the E naught, or if this number here is most, or is how do I put this? If the number is more positive, then the half reaction stays exactly how it is. So plus 1.51 is more positive, then this half reaction will stay the way it is. 4 minus, I'm just gonna write it down, 8H plus If you didn't understand that, is very important. Just ask me. Mn O 2 plus 4 water. Then the one that is least positive is the one that is gonna swap. So you can see I'm gonna swap the zinc to look the other way. Zinc 2 plus 2 electrons. So now I have my 2 half reactions. Now I can answer those questions that they have. The first question was, just need to go back to see that. Write down the reducing agent. So we already know which one is oxidized and which one is reduced. Which half reaction is showing oxidation? On
The
top or on the
zinc.
bottom? The zinc.
Okay. Mm.
Yes, this is the loss of electrons, oxidation. The one on top is reduction because it's the gain of electrons. Reduction. Then where do we find a reducing agent?
The reducing agent anode. Wait. Yeah, I think so. Red
Yeah, I
cat.
was be careful with that, but yeah,
Cathode. Cathode.
okay, remember
Red.
reduction is red cat, right? So reduction
Mm.
cathode, the anode and ox.
And ox.
Yeah,
Did Sir say the reducing agent?
so say that again.
Did Sir say the reducing agent?
Yes, we need the reducing agent.
It's going to be zinc, sir.
Okay, and what's the reason for that?
Because usually the one that undergoes oxidation will be the one that is a
Reducing
reducing
agent.
agent, and then the other
Correct.
one is going to be the oxidation agent.
Correct. That is what we're looking for. So we didn't need to look at the cathode and anode. We just need to know which one is oxidized, and the one that is oxidized is the one that is called the reducing agent. That's a very correct answer. So zinc is our reducing agent. And then now for a oxidizing agent, do we pick this one or this one, or is it both?
For what?
For the oxidizing agent,
Uh, I think you're picking the first part. Why are we taking the H? We can't. Or can we?
okay, maybe do some research, but it's gonna be the main reactant,
Yes,
right? Yeah, the H is just there because we acidified the solution, but the main thing, the main reactant is MnO4 minus. Okay,
yes.
so that's your oxidizing agent. Okay, cool. But we have question number 2, which says, let me just scroll up. It says refer to the relative strength of oxidizing agent to explain why a redox reaction is taking place. Okay, that's a good question. Why did this reaction take place? Yes?
Angry, the zinc is the zinc ions. I don't know if it's zinc or you say zinc ions. But the Zn2 plus
Yep.
is a weaker oxidizing agent. So
Yeah.
the permanganate will be reduced.
Okay, that's a good one. And yes, it is correct, of course. So we're going to look at these ions, zinc 2 plus and permanganate ions. And we see that the permanganates, if you look at this side here, the arrow that is facing down, you're just going to say what you see. You're going to say MnO4 minus is a stronger oxidizing agent than zinc 2 plus ions? Yes. Therefore, the zinc metal will then have to be oxidized because it is reacting with
So,
a strong oxidizing agent. Yes.
um, I think I always go with the opposing. For example, like what Litabo did. Is that wrong?
You mean, can you just?
When you speak about the zinc instead of the main
Oh, okay.
thing they want,
So what would you say in this case?
the same thing as Litabo said, but she spoke about the zinc instead of what Sir was speaking about now. Is it wrong? Because sometimes on the memo, then we only see they speak about the agent that they wanted you to speak about. She
It
spoke
it
about the reducing agent instead of
yeah.
oxidizing agent.
Yeah, it doesn't really matter. Like you can say zinc 2 plus is a stronger reducing agent than MnO4. Therefore, this will force MnO4 to be reduced. You can put it in two ways. And in the memo also they will have two options.
Okay, so
Yeah, those both two answers are correct. Just make sure you know what you need to include. That answer, that question is 3 marks, so you need to mention. I'll use this part where I'll say MnO4 is a strong oxidizing agent than zinc 2 plus ions. So already there I mentioned 2 points, so I'm gonna get 2 marks for that. Then I can say this means zinc will have to be oxidized, and that will make sure that I get my 3 marks. Okay. The reaction wouldn't have happened if zinc was a stronger oxidizing agent, because now zinc will refuse to switch directions. So we'll see nothing happening in the test tube. But now what we're going to see in the test tube on the theoretical level is that the zinc will start to disappear. Why? Because it's turning into zinc 2 plus solution by losing those 2 electrons. So at the end, we're not gonna see any zinc left in the test tube. That's what the question means. Okay. Then we answered those two. 8.2. We'll see how far we'll go. A standard electrochemical cell is set up as shown below. 8.2.1. Or maybe we can just like destroy everything before we even go to the questions. We can already write the half reactions, or can we? Sometimes they'll give you a clue. Like in this case, they'll show the direction of electrons if they want, or they'll show which one is the cathode and stuff like that. But I don't see any of those right now, so we'll just proceed with the questions. But we can see that we have nickel on one side, accompanied by nickel 2 plus ions as an electrolyte. We have Mn as the electrode on the other side, accompanied by Mn2 plus ions as the electrolyte. Then there's a salt bridge labeled Y, and I assume they'll want the function of that. Okay, 8.2.1, write down the function of component Y, and it's 1 mark, so you just need one function. Which one comes into your mind immediately?
Completes the second.
Okay, it completes the second, and I think that one really we should like maybe proceed to say something else. By doing what? Just to be safe.
Electrical neutrality.
Okay, it completes the second
Neutrality.
by
It
maintaining or electrical neutrality. Yeah, that's good. I think if that can even qualify as two reasons, but it's fine. Another reason you can give is that it provides a path for the movement of ions. Okay, couple of them. 8.2.2, in which direction will electrons flow in the external circuit? Choose from Ni to Mn or from Mn to Ni. Oh, okay, in fact, we could have already destroyed the whole thing. Why? Because this is a spontaneous reaction, which means it has to always end up with a E0 cell of positive. So let me show you what you need to do quickly before you even go to the questions. Let me erase this so that we can work on that. So our half reaction includes nickel and Mn. So you go right down to the reduction potentials. Let's highlight nickel and Mn. Once again, you'll help me with the E0 values once you spot them.
We're looking for Mn and Ni.
Mn 2 plus and Ni 2 plus.
It is 1,18.
1,18 positive. Okay, let's see. Yep, that is correct. So it's all the way down there. I can't fit the whole thing in the page, so maybe I need to scroll down to find the other one. But yeah, that's a good spot. Where is the nickel? Oh yes, negative 0.27. Thank you. Sharp eyes. I would have spent like maybe 10 minutes looking for this. I'm kidding. Maybe 2. Yeah, but yeah, sharp eyes there. Okay, then once again, I'm using 4A for this one, by the way. But always you're going to look for the half reaction with the
So for
most.
this opposite, Mn is up and Ni is down.
Right, but usually I won't mention down and up just so that I don't confuse people who use different versions of the tables. I'll just say the one with the most positive E0 stays the same. Okay, most positive E0, or let's say high E0, doesn't change, doesn't swap. So this means you can see negative 0.27 is higher or more positive than negative 1,18. Therefore, the nickel half reaction doesn't swap. So nickel 2 plus 2 electrons gives us nickel solid. And the other half reaction will have to swap. So you're going to have Mn 2 plus, Mn solid, giving us Mn 2 plus 2 electrons. If you didn't understand this part, it's important that you ask. Therefore, from here, I can already identify the reduction, the oxidation, the cathode, the anode, stuff like that. So let me just copy this and put them on the question itself. So the E0 for this one is negative 0.27 and the E0 for the other one is negative 1,18 volts. Okay, let me just copy. Then I'm just going to post it on that question so that we now look at what to do. All right. Then, which half reaction represents a reduction?
The first one.
The first one is a reduction because we have the gain of electrons. That is true. So I'm just going to label that one as a reduction. And remember, reduction goes with the cathode. So you're just going to write red cat. And then on the bottom, I'm going to write oxidation and anode. So NOx. Okay, cool. Then, okay, I could do the E0 cell, but I presume that there's going to be that question. And I could do the net ionic reaction. but I presume that question could be there as well. So let's just follow the questions. Okay, then the question was, in which direction will electrons flow? Is it from nickel to Mn or from Mn to nickel? What do we say?
Mn to nickel.
Mn to nickel, and that's correct because Mn is losing electrons, nickel is happy to take them. So the electrons have to flow up from the manganese to electrons, go all the way to the external circuit, flow all the way to the nickel side so that the nickel can grab them to become reduced. So we can even talk about which one will gain mass and which one will lose mass. I don't know if that question is there, but it's an important question. So which one is expected to gain mass? The two electrodes.
Wait, what's that?
Which electrode is expected to gain mass? Which one will get bigger with time?
I'm not sure.
Okay, anyone else with an idea?
I think it's nickel. I don't know.
Okay, maybe we don't really understand the theory behind it, but it's fine. If we say something is being oxidized, see if this is Mn, then we are basically saying that it's being like eaten away. It's being eaten away. A portion of that is gonna go away and drop into solution as Mn2 plus. So it's going down in terms of mass. And if we say something is being reduced, contrary to what you might think reduction means, but if we say it's being reduced, it means it's gaining mass. In other words, if it's picking up the electrons, here are the two electrons that are coming in, then the nickel that was in solution will come and attach there, making the nickel bigger. So nickel, by gaining electrons, it's also gaining mass.
I have a question.
Yes.
So for the Mn2 plus, is it the N ions or the cat ions?
The Mn2 plus, is it the cat ions or the N ions? Is that the question?
Yes.
Cat ions and N ions. Cat ions are positive ions. That's all we know. N ions are negative ions. Right? So I'm not sure if that question is for this, or maybe you're confusing something.
No, because I saw. I don't think it was this one. You see that one, yeah. The spoon one with the impure things.
Yeah.
Yeah, there was something about. I wrote it in my notes, Maraka Fit. Something about N ions, cat ions attracting. Some will go to the other side.
Oh, okay. Yeah, I know what you're talking about. That's like in electrolytic cells, whereby maybe let's say you have sodium positive and chlorine negative. That's a completely different cell, because that one is going to be run by a battery. It's not going to be spontaneous. So then the one that are positive will be attracted to the negative electrode. The one that are negative will be attracted to the positive electrode. But
Yes.
yeah, N ions by definitions are negative. Cat ions by definition are positive.
Yeah.
Okay.
You answered me.
All right. Thank you. Then, okay, we already established the direction of electrons. That's 2 marks. That's a lot. Because they know you have to do this in order to find the answer. So that's why it's 2 marks. 8.2.3, calculate the initial EMF. Don't be thrown off by the word initial. That's just the E naught that the cell will have. The reason why they say initial is because eventually it's going to die down to 0. Yeah, so I like to use the equation, and there's a reason behind it. If you go with some teachers will say, okay, the one that swaps then becomes a positive, like here, but I don't like to do that. I like to just say, use the equations, and the equations just show you here. There's like 3 versions. Depending on what you know, you can use E cathode minus E anode, E reduction minus E oxidation, and maybe this one can really mess you up. Oxidizing agent and reducing agent. Why would you want to do that? So let's pick reduction and oxidation and calculate the answer. So you go and write your equation down. Why? Because there's gonna be a mark for that. So E naught cell is equal to E naught, it should be reduction first, reduction minus E naught oxidation. Then the reduction half reaction has an E naught of negative 0.27. The oxidation half reaction has an E naught of negative 1.18. Then what do we get as the answer?
0.91.
0.91, and that's positive, right? Volts. Yep, the way they'll mark is they'll give you a mark for the formula. They'll give you 2 marks for the correct substitution, and then 1 mark for the final answer. All in all, that's 4. Quite generous, because this one is like simple. After you identified your half reactions, then it should be simple. Write down the balanced equation for net cell reaction. Once again, that is something you could have done initially, but I wanted to follow the questions, so let's do it now. You just need to cancel the electrons on either side. So on the reduction, I cancel. On the oxidation, I cancel. And I just take everything down and write them here. So I have nickel 2 plus on the reactant side plus Mn on that oxidation half reaction. Then this is going to give me nickel solid plus Mn 2 plus. And that is it for 3 marks. No answer for no answer for parking for method. All the 3 marks are going to come from that final answer. So they'll give you, yes?
If we had to balance, was it going to be 3 marks?
It is actually 3 marks because they are marking balancing as well.
So if I had to times by 3 by 2, then it's still 3 marks.
Yes, of course. Even if it's hard to balance, but it's still 3 marks.
Yeah.
Okay, you like to complain about fairness. Maybe you'll be an examiner one day, who knows? And you'll feel like, no, they don't deserve like 4 marks. Come on.
I
Okay.
will make them pass. I'm not like them.
I'm not sure about that. I mean, when you are a teacher, because now you are a student, you feel like, ish, these things are not fair. But when you're a teacher, you're like, hey, I struggled also. So these people need to study as well. And you'll feel like that.
Actually, very. So I was very sharp.
Next year at university, you'll feel what I'm talking about. You'll see what the professors will do. Now you're dealing with professors, people who went through a lot of struggles. Imagine getting your PhD and like teaching for like 5 or more years. So it's gonna get really, really tough. Okay, but don't be scared. Just pass, and then university can be fun. 8.2.5, the concentration of nickel 2 plus aqueous is now increased. Okay, they like these questions, guys. Just make sure you
And that's
understand.
just wrong.
Yeah, it's easy to get them wrong, especially if you see the theory questions. If you don't understand the theory, guys, there's no way you can always. If you try to guess, you can guess, but if you don't understand the theory, that's a recipe for disaster. But let's see. Concentration of nickel 2 plus is increased. Will the reading on the voltmeter increase, decrease, or remain the same? So here's how to answer this one. It's an application of Le Chatelier's principle, actually. So let me just copy this and paste it down here so that we just quickly look at it. Sometimes that question can be 3 marks because they'll want the reason. And they'll say use Le Chatelier's principle to explain. So here's the half reaction, right? And I'm now going to increase the concentration of nickel. And I'm asking myself, is this good for the cell? So anyone who remembers Le Chatelier's principle, what's going to happen if I increase the concentration of a reactant?
It will favor I don't know the forward.
It will favor the forward. Okay. Do you all agree? Can just hit the show button, or if you don't agree, just say.
I don't agree with myself. I'm not sure with my answer.
You're not sure. Okay. Anyone else? What do you think?
I agree, so.
You agree? It's gonna favor the forward.
Reaction.
All right. Is that good for the cell? Or in other words, will that increase the voltage?
I think so.
Okay. Okay, guys, these questions are like this. First of all, you deal with the Le Chatelier part, and you are correct. If I increase the concentration of a reactant, then the reaction will proceed in a way that it's going to try to finish up that reactant. So it's going to push it down. In that method, it's going to be favoring the forward. And the forward is producing more nickel solid. So is this good for the cell? That's the question. And the answer, the simple answer is yes. Okay, can we mute? Let me just mute him. You'll unmute if you have a question there. Okay. So here's the thing. Nickel is receiving electrons, right? Plus 2 electrons. So if I'm favoring the forward, it means this maintains the same configuration. It's still going to proceed the way we want it to be. But if let me just reason this by doing a vice versa. If I reduce the concentration of nickel, then the reaction has to favor the reverse, which means the half reaction will be like this. Nickel becomes nickel 2 plus 2 electrons. Now nickel, instead of receiving electrons, it wants to give away electrons. But Mn also want to give away electrons. So that's a conflict, and that will make the cell die immediately, because you are having two half reactions that are trying to do the same thing. I don't know if that makes sense.
A little bit.
Yeah, it's just because maybe you it's the first time you are like hearing about it. But if you favor the wrong direction of the arrow, that is bad for the cell, because now the half reactions are going to be wanting to do the same thing. Okay, so in terms of giving a reason, it could be 4 marks or 3 marks. That's what you have to say. So first you explain the Le Chatelier part, and then you say it's going to maintain the same half reaction, then yeah, stuff like that. But you can see in the previous memos as well, if you research or if you practice. Okay, maybe let's do this question on electrolytic cells. So you already done.
So,
Yes.
was the answer remain or increase or decrease?
Increase.
Okay, maybe the reason was not good enough if you're not sure which one to choose, but it's increase. It's gonna conform with the configuration of the cell. It's gonna, like, it's even gonna make the voltage high because now more electrons are produced, which means more voltage is produced.
Yes.
All right, cool. Then electrolytic. It says the diagram below represents a simplified cell used for the electrolysis of concentrated chromium 3 chloride, and chromium 3 is just Cr3 plus. Then chromium 3 chloride is Cr3 plus chloride. Electrode R and T are made of carbon, and like that's not a surprise because in electrolytic, if we just want to break down something, we make the same electrode material, and usually we use carbon or platinum. The net cell reaction is this. So you're going to have the breaking down. This is decomposition. The breaking down of chromium 3 chloride to chromium solid and chlorine gas. 9.1 define electrolysis. Anyone who remembers this definition?
Chemical process where electrical energy is converted into chemical energy.
Exactly. So we are using electricity to make chemistry. So if you mention that part, you are good. Okay. 9.2. Note the graph below, not drawn to scale, represent the changes in the mass of electrode T during electrolysis. Okay, you see the mass thing came in the electrolysis part, but it can also come in the galvanic, right?
Wait, sir.
Yes.
What's the function of the R&T stuff?
Also, the R and T are just electrodes in this case. The decomposition is
The things that they are made out of, that thing.
the carbon. The carbon is not gonna do anything in the reaction. It's just gonna help break apart the molecule. Yeah, that's a good question though. So the graph here will give you some idea into what's going on in the circuit or in the cell. So mass of electrode T is the one that is increasing because at time 0 we start with an electrode that weighs 2.2 grams. After 10 hours we now have X grams, which is higher than 2.2. So it means on this electrode, on the T electrode, we are gaining mass. That should already tell you something about whether T is positive or negative. I don't know if you see that or not.
Can you please repeat?
So the fact that T is gaining mass should already tell you that which one is positive and which one is negative. R and T. So let's break it down. Don't be scared, we'll break it down for you. So in the electrolyte we have Cr3 plus ions, which are aqueous, and we also have chloride ions, which are also aqueous. We have those two ions. Then chlorine, if chlorine changes, it's gonna change into a gas. If chromium changes, it's gonna change into a solid. That's the reaction that you're given here. So does the solid or the gas, or which one between the solid and the gas will make the electrode increase in mass? Is it a gas or a solid that is going to make T increase in mass? Anyone who can help each other, because now we're just studying together. When you are alone,
So solid. Gas is A.
yeah, gas is just gonna go away. It's not gonna stick. The solid is the one that's gonna stick and make the mass go up. So that was a simple question, and if you found it hard, it means there's a problem a little bit. So this means the T is the one that is picking up chromium 3 plus to make it chromium solid. Then I can already write the half reaction. On T, we have chromium 3 plus becoming chromium solid, and therefore it's gaining electrons. So I'm just gonna move this to the other side and show that it's gaining electrons. I mean, unless if you are getting tired, this should be really simple to think about. Then on R, we are producing the chloride gas. Therefore, we have chlorine minus, which is losing electrons to become chlorine gas. And I just need to balance by multiplying by 2 there. Let's look at this. It might not make sense, then I'll have to explain again. Anyone who doesn't understand what happened, how do I figure out the half reactions happening at T and R? All understand?
Fine.
Okay. So the fact that T gains mass, it means that it's the one that is reducing, or is the one that a reduction is taking place so that it can gain mass. On the R, the gas is just gonna flow away. So when the chloride come in, it's gonna lose those electrons and it's gonna just fly because it's gas. Okay. Therefore, now we can even like do what we can. Let's just see what the questions say. Why not? Because now we already established which one is reduction and which one is oxidation. Always remember your red cat and ox. Yeah, they don't change. Then another thing I think that is important to remember is in electrolytic, which one is positive, cathode or anode? Which one is positive?
Anode. Anode is positive.
Okay, so the anode is the one that is positive. So anode there, cathode there. Okay, let's go to the questions. Write down the half reaction that takes place at T. We already did that. So I said to you, they'll give you a clue. You see, on galvanic, the clue was that they gave you the things that you need to know. They could have said the other one is X. Then if they do that, then they have to give you another clue. And that clue can be the direction of electrons, or it can be, they can label which one is the cathode, stuff like that. I mean, you'll revise today and tomorrow, and if you have questions, you'll ask me and I'll explain it to you. Okay, then they say a current of 2.5 amps passes through the cell for 10 hours. So let me write that information down. Current is 2.5 amps in a duration of 10 hours. Calculate the total charge that flows through the cell during this time. Calculate the total charge due to that current and time. And don't need to stress, you can go to the formulas and you will find the formula that you need. There's the formula that says charge is current times time. So simple, 3 marks question. Just go and substitute your stuff. The only thing to remember is that time should be given in seconds. So how do we convert that to seconds?
You multiply by a minute is 60 seconds.
Mm-hmm.
An hour is 360. I don't know.
So a minute, an hour,
6.
yeah, an hour has 60 minutes. A minute has 60 seconds. So I should multiply by 3,600, actually, not 360.
3,600.
Yes. Or just multiply by 260s, just to avoid mistakes. Yeah. Then what is the charge in coulombs?
90,000.
90,000 coulombs. Okay, that's good. 3 marks, so it doesn't come as a surprise that you'll get the marks like that. Okay, then the next question, this was 9.2.2. 9.2.3, which is the last question for this one. Calculate the value of x as shown on the graph. Let's see how many people are thrown off by this question. Let's say you are in the exam. How many of you feel like, nah, I can't do this one, to be honest? You are given a graph and that schematic, and then they say calculate the value of x. Solve for x.
On my side, I think it's in a way.
You think? You said you think it's gonna...
I think it's my network. You were breaking.
Okay, let's say like you haven't started, so you're not sure what to do. But again, if when you get to a question already, if you read the stuff that you have in your mind, you can say, yeah, I know what they want me to do. I know exactly what they want me to do. So I want to understand if you already know what they want you to do or not.
I think I have an idea.
You have an idea. That's good. That's good. Others, you see this question in the exam, how do you feel? Do you know what they want? Or you're just gonna put the ink on the paper and hope for the best? Or even skip it blank? No answer. Okay. That's fine. All right. We are looking for the mass of electrode T at the end of the day. So let's see what we need to do. I did a couple of these kind of questions, by the way. Yeah. So we have the charge, and you know what we can do with that charge is, let me grab this pen. Or maybe you wanna like tell me what you wanna do here.
Oh, Just know we have to find the electrons first.
Okay, we have to find the electrons.
That's because we have our charge.
That's
So
exactly
we
correct.
can use the E on our formula sheet.
Yes, that's what you're looking for. Because again, you have to go to stoichiometry and you have information charge is carried in electrons. So you have information for electrons and you can use that information for electrons to relate to the information about the chromium. Remember, T stands for chromium in this case. So I'm going to write the half reaction down. Chromium 3 plus gains 3 electrons to become chromium solid. Then I'm gonna say, okay, since I know the charge, I can find the amount of electrons that are being transferred in this reaction. And I can do that with the help of this equation. Just scroll down to the formula sheet and you'll see an equation that says the number of electrons is equal to the charge over the charge on an electron. It's two versions of the same formula. You can decide which one you like, but they mean the same thing. Basically, I'll use the one that the information sheet is in terms of, so that in the test you don't be like, where's that QA now? So the information sheet is in terms of E, then I'll use the one that divides Q by E. But E and QE is the same exact thing. So it's going to be Q is N is equal to Q over E. Then we can substitute our values. The value of E is that one there in the information, by the way. So N for electrons is equal to Q over QE, or just E. Then I substitute. Now you see I'm gonna specify that I'm finding the number of moles of electrons is equal to the charge is 90,000. Charge on an electron, you can substitute it as a negative, but that doesn't matter. And if you use this equation enough, you'll know that the negative doesn't really matter. The negative just tells you that an electron is negative. So at the end of the day, I'm gonna need a positive answer for this. So what do we get? I guess it should be in scientific because it's supposed to be a very large number.
Of 5,63 times 10 to the power of 23.
Okay, then for the units, what do we put down?
Electron.
Electrons. Exactly, because this equation says the number of electrons. This is the number of electrons. You might really confuse it with the number of moles, but it's not the number of moles, it's actually the number or the count. How many people do we have in this lesson, as opposed to what is the number of moles of something. So just be careful with that. That's not the moles, that's the number of electrons. Okay, now we have to find the moles though. So how do we find the number of moles of these electrons?
And if you
I can scroll down to the formula sheet if you want.
Yes,
Okay. So which one are we looking for?
can we use the Avogadro's formula?
Yes. Like
yes.
there's no question there, guys. Why? Because we are dealing with the number of something. Every time you have number of something, it's
So we're gonna
always,
use the second one. The one next to the other one.
sorry.
Are we gonna use the second one?
Yes,
Like,
what I was saying is that, guys, it seems like, you know what I hate is guessing, because guessing doesn't always work out. You have to know exactly what you're doing. And in this case, we are dealing with the number of electrons. So I'm going to choose an equation that has the number of something. And that's the Avogadro's equation. The one that says number of moles is equal to the number of molecules over the Avogadro's number. That's the only reason why we choose that one. If we knew the moles of electrons or whatever else, or the volume of electrons, if that's possible, then I'll use the one that maybe has volume, but that's actually nonsense. I'm just making an example that you don't have to guess. You always know what you're dealing with. Okay, then the Avogadro's number, if I can just highlight it for you, it's a constant. There it is. So I can find the number of moles of these electrons now. So number of moles is equal to N over Na. Then in the substitution, I say the number of moles of electrons. Maybe you see this N. I really hate this small letter N. Maybe let's just use the big letter N. Why not just use big letter N for that? Because it really conflicts with the number of electrons or the number of moles. Okay, so if we substitute, this is 5,63 times 10 to the power 23 electrons over Avogadro's number, which is 6.02 times 10 to the power 23. And then what do we get? Quick.
Yeah. Yes. You're 9,35
9,35 times
10 to the power minus 1.
times 10 to the power negative 1. Okay. Times 10 to the power negative 1. Not significant. We should write this as like a simple decimal.
Okay. It's 0,935.
0,935. Good. That one looks right. It's not that the answer is wrong. It's just that it's not good enough to just convert that to scientific if it's a smaller Nyana value. So that's good. We now know the number of moles of electrons. Then we can use the ratios to find the number of moles of the chromium. And that's your step 3. We'll say chromium versus electrons. And someone might ask, is a chromium 2 plus, 3 plus, or chromium? What would you say?
Wait, what was your question?
Are we dealing with chromium 3 plus or just chromium solid?
Chromium solid.
Yes, we can only talk of like the mass of electrode. Remember, you are dealing with the mass of electrode, and an electrode is a solid. It's not an aqueous. The reason why I say this is because you might make a mistake and think you are dealing with chromium 3 plus, but in this case you are dealing with a solid. Then the coefficients from the balanced half reaction is 1 chromium versus 3 electrons. It's just like how we've been doing ratios all the time. Then we know the number of moles of electrons. Then we can just put an N or X for the other side, cross multiply. Then you'll have 3 times N for chromium is equal to 1 times 0,935. Divide by 3 both sides. What do we get?
0,31.
1,31.
0,31.
0,31. Okay. Mole. Don't forget the units. Then from there, it's just finding the mass, and like that's like the simplest step. Step 4. It looks long, but once you establish what you're doing, it's not long. Then if I write the mass as the subject of the formula, 0.31. What is the molar mass of chromium?
52.
52. Then what is the final answer?
16,2.
60. No. You say 16.
Yes.
16,12. And that's grams. So there it is. 6 marks. Looks long if I just scroll up a little bit.
So shouldn't we add the one that we were given before, the 2.2?
Oh yes,
As
because we are looking for the value of x. Yes, that's a good point. Oh wow, they really made this one long. Maybe it should have been 7 marks or something. I'll just call it step 5 because it's not included in the calculation. So we just need to say x is equal to 16,12 plus the initial 2,2. I think this makes 18,32 grams. And that's the final answer. Okay. Any question on this one?
No.
Anyone else who have a question? I can scroll up and you can check what we did. And this question can be flipped. They can give you the mass and ask you to find the charge. And you're just going to be working in reverse from what we did. Tao is laughing. But ultimately, it comes down to finding the number of moles. If you get the mass, then you find the number of moles of chromium. Then you relate that to electrons using the ratios. From number of moles of electrons, you find the number of electrons. From the number of electrons, you can find the charge. So the game is between the ratios and the number of moles. Stoichiometry all the time in chemistry. Okay, and that's it for this question. And yeah, probably for electrolytic or for electro, but again, the name of the chapter, electrochemistry. This is the stuff that you need to know before you go to the exam. I feel like this question paper addressed everything. So it should be good.
The membrane part.
Or not the membrane. Yeah, that one is always left out. And then it's going to show up sometimes. You never know what time it's going to show up.
I have a feeling but pointer.
Even though it was there in the trial.
Yeah.
For Gauteng.
Because some provinces didn't have it. And the new examiner unique man.
Yeah, the ones for this year, they are on something. Ne?
I don't know, they didn't enjoy their matric or things like no.
Can you guys tell me the provinces you are coming from? Just I wanna check something. Leta was from Gauteng. Donald Limpopo. Ne?
Now, the negative
Oh, he's in class also. Okay. Aviwe, you were saying?
I'm from Western Cape, so
Western Cape. Okay, Entle. Maybe she's not here. Okay. All right, fine. Let's see. Let me just scroll up on this question paper, and you guys can tell me if you want me to do any more question. This one is acids and bases, you always like expect to get that longer question at the end for acids and bases. Some people find it easy and straightforward to follow. And that's what I think. You have chemical equilibrium. There's Kc in that one. Also a lot of marks. Then from there it's just organic chemistry. And I feel like maybe organic chemistry, as far as I'm concerned, Deletabo, you must be okay with that one, right?
Yes, this one and acids and bases are.
Yeah,
I
good.
must have them.
Okay, that's good. Then let's see. Chemical equilibrium. Is there any problem with that?
I don't know if I should say a problem or silly mistakes.
But in terms of the theory, everything is sharp.
Yes.
Yeah, that's good. Okay, let's browse through it then for like 5 minutes and see what you guys are at. They say carbon, C, solid, reacts with sulfur, S, gas. According to the following balanced equation, the system reaches equilibrium at T in a sealed container of 2 decimeter cubed. The Kc value is given at that particular temperature. We know Kc is defined for temperature. And then they say state Le Chatelier's principle. Do you remember it in words?
The Chatelier principle. I think I do.
Yeah, give it a shot. Let's hear.
When the equilibrium in a closed when when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance.
Yeah, this you can't get any more perfect than that. That's perfect. That's exactly how it is. Okay, that one is in the bag. And then they say at equilibrium 1 mole of carbon disulfide CS2, which is the only product, is present in the container. Calculate the concentration of sulfur present at equilibrium. What do you think you need to do for this?
I'm very this is the easy one. It's not the complicated one.
You see?
You going to say the product? Oh, wait, let me think about it.
Okay.
Casey is 9.4.
Yes.
But then also, we don't include what? The solid and the liquid. Nah.
Yes.
So we're going to say CS2 divided by S squared.
Yes, that's true. So we don't even have to draw the table because we are dealing with stuff at equilibrium and we have the Kc. So we jump straight into Kc and say Kc is equal to the concentration of CS2 to the power 1 divided by the concentration of S to the power 2. Right? Yes, then we substitute, it's just 9.4 is equal to the concentration of this other guy is given 1 mole, so 1 over S squared. So yeah, that one we just need to do this.
Wait.
Yes.
It's more. It's not. Are we not supposed to have C equals to N over V? We have the moles.
Oh,
We can't write
yes.
moles there. So it's going to be 1/2, which is 0.5.
Ah, yes, yes, you are focused. Hey, that's good. So you need to first find the concentration because that's the moles. Okay, so the concentration of CS2 will be given by the number of moles over the volume, and that's 1 over volume of 2, so 0.5 mole per decimeter cubed. Okay, very good. Then we substitute 0.5 there. Then what is the answer that we get?
0.23
0.23, the units,
mole per decimeter cubed.
mole per decimeter cubed. There it is, simple. 4 marks, so I presume they'll mark the concentration of CS2 and then they'll give you a mark for the equation for Kc, substitution, final mark. So 4 marks in total for this. Okay. Then let's see the reasoning questions and then maybe we can stop there too. They say the volume of the container is now doubled at the same temperature. After a while, a new equilibrium is established. Then they say, how will the amount of S gas change as this new equilibrium is established? Choose from increase, decrease, or remain the same, and also explain the answer using Le Chatelier's principle. So what is our answer here? Think about it.
The volume of the container is not doubled. Temp. If we increase the volume,
Yes.
I don't know my answer if it's increase, decrease, or remain the same. But I know, looking Le Chatelier's principle, if you increase your volume, you're decreasing the pressure because they're inversely proportional. Then
Yeah.
after, the reaction that has the biggest number of moles will be favored.
Yep, that's correct. And
Then
okay, let's see what we need to do.
more favored.
Yes, so decreasing the volume or increasing the volume because we are doubling it. Increasing the volume, decrease the pressure. So if we decrease the pressure, we favor the side with the most amount of molecules. Yes. So this is the reverse that is favored, right? Do you agree?
So wait. The reactant will be favored because it has the greatest number of moles.
Yes. So if we increase the volume, we are favoring the reverse, and that means we are favoring sulfur because sulfur is in the reverse.
Yeah.
Yeah. So to answer that question, we're gonna say it's going to increase. Yes.
Okay.
To give a reason, we say it's favoring the reverse. You're gonna say according to Le Chatelier's principle, or before that, increasing the volume, decrease the pressure. Then according to Le Chatelier's principle, decreasing the pressure will favor the side with the most molecules. So increasing the pressure will favor, decreasing the pressure will favor the side that produces more molecules. And when that happens, it means you are favoring the reverse. And that's it. This is like how many marks? 3 marks. So you already have 3 points there. for the 3 marks. Let me just repeat it for Kanya because it's also doing chemical equilibrium. So if we reduce the volume, remember we don't really focus on the solid. So this one is actually out. It's not gonna be 3 molecules versus 1. It's gonna be 2. Why? Because the solid doesn't change even if I reduce the pressure. I don't know if that makes sense. So the solid is not there. If you're gonna mention molecules, do not say 3. Say 2. So increasing the volume, decrease the pressure, and
So
yes,
if the C was a gas,
yes,
were we going to include it?
yes. If it was a gas or aqueous, we were going to include it.
Okay.
Yeah. So in other words, if this side was like, if we had something else, maybe 2, whatever. I'm just giving an example. Therefore, this side has 3 molecules. This side has only 2 because the other one is a solid and it doesn't count.
Okay.
Yeah. Okay. So yeah, that's again, remember the way of reasoning this is also included in the notes that we have. So just make sure you don't lose any mark out of that 3. Make sure you count it in. Okay. Then 6.5, it's gonna be about KC. Just looking at the marks. Do we do it or do we maybe go to the 6.6, which is about reasoning?
No, let's go to reasoning.
Okay, maybe if we have a little bit of time, those will remain behind, will remain for that question because it includes X
Because
and
we
many.
once did.
Or you want?
Remember, our a similar question was confused if we subtract or add
Oh,
more
oh yeah.
the equilibrium part.
Okay.
So I'm fine. I don't know about the other ones.
Yeah, maybe Kanya will want us to go through it. I don't know, but we'll see. Okay, 6.6, it says the reaction rate time graph below represent further changes made to the equilibrium mixture. The volume of the container is kept constant. Okay, so you see here they give us the reaction rate time graph. What other graph could have came in a different exam?
Concentration.
Concentration time. And they are different a little bit because concentration time is looking at the individual concentrations, while the reaction rate just looks at the reaction or the rate of the forward and reverse. And here the forward is in a solid black line, the reverse is in a dotted. So let's see the questions. 6.6.1, what do the parallel lines between TA and TB represent?
The rate of the reverse and the forward are equal.
Okay, the rate of the reverse and forward are equal. Okay, I'll take that. Kanya, what would you have said? What does those parallel lines represent?
It's a pronouns.
It's there?
So I'm not sure.
Not sure. Okay. Okay, let
I
me go
have a
to
question.
Letaba. Yes.
Is it wrong if I also say so between? I want to know which one is more correct. Okay.
Sure. Yes.
Between the rate of the reverse and the forward reaction are equal and the at equilibrium, which one is correct?
Both of them are equally correct. So in terms of one
Okay.
word, you'll say the reaction is at equilibrium. In terms of explaining, you'll say the forward is equal to the reverse. But if I were to choose, I'll say equilibrium because It is equal, but what is it representing? It's representing equilibrium. So we'll just go with equilibrium for this. Okay, equilibrium. Good. What change was made to the equilibrium mixture at TB? Right there, what happened to the mixture?
Increase in wait. This is according to the equation that we got.
Yeah.
That straight line and a curve. It's something that has to do with concentration.
Yep.
So I'm going to say increase in concentration because it's not going down and increasing. It's going up and decreasing. Yeah, increase in concentration.
Okay, increase in concentration is correct. However, you will not get that mark. I don't know if you notice why.
Because I didn't specify which concentration.
Exactly, yes. Can I have to
Increase
specify?
in the concentration of the reactant, which is the sulfur.
Okay, that's good. How do we know it's the reactant that is being increased?
Forward and reverse.
Okay, because at the end of the day, we are favoring the reverse, but the forward is the one that is shoots. The reaction rate of the forward is the one that is shooting up, and yeah. So, okay, we're just gonna say. Let me just write in symbols. We're just gonna say the concentration of the reactant. Concentration of reactant, or you can specify which reactant. It's sulfur because only sulfur can go into equilibrium. The other reactant is a solid, which is copper, so it just basically acts as a catalyst for the reaction to proceed, but it doesn't do anything at equilibrium. Okay, 6.6.3. Give a reason for the sudden change in the reaction rate at TC. Now looking at TC, why do we have that change? Let's look at what happens, what kind of transition we see there.
The forward decreases. Wait, it's constant.
The forward is a constant.
Wait, no. I'm trying to think of my graphs.
Yeah, think about it.
TP is constant. TC is temperature. That transition there, it's temperature, but
okay. First of all, how do we know its temperature?
Because of I don't know how to explain it. I now remember how it was
How
on
it
the
looked
graphs.
like.
Yeah.
Okay. That's good enough for the exam if
That's
you know.
I can't explain if it increases or decreases, but I know that transition rate. It's about temperature.
Okay. Then
But
look at what the reaction, what the equilibrium is doing. Does equilibrium does the reaction rates shift up when we increase temperature, when we decrease? Okay, let me say, does the reaction rate go down when we increase or decrease temperature, according to reaction rate chapter?
does the reaction rate go down if
Increase.
what?
Does the reaction rate increase or decrease if we increase temperature.
Increase in temperature.
Yes, increase in
I
temperature,
think
increase rate of reaction,
I
or decrease.
increase in temperature increases the rate of reaction.
Exactly. So here what we see is that the rate of reaction actually decrease. So what did we do to temperature?
We decrease the temperature.
Yes, that's how to actually see that.
Okay.
Yeah.
Decrease in temperature. Then our reverse will be favored.
Yep.
Then
Okay.
the forward reaction will decrease. Okay, makes sense.
Cool. Then they want
Okay.
a full explanation of that actually.
Both the forward and the reverse reaction decrease.
Yes. Therefore, you're
Then
just gonna say what you see there. Then which one is actually favored at the end?
the reverse is favored.
Yes. Okay. Then you can just
I
say
don't
the other
know.
one is it decreases or whatever.
Oh, with temperature, you have to include endothermic and exothermic. You actually get a mark for that.
Oh yes, yeah. Especially when you're given the concentration graphs. These ones to me are a different beast altogether. But yeah, the concentration ones make sense a little bit better. So that information, though it was given on the information here, they give us the enthalpy as positive, which means endothermic. Okay. Any endothermic
Oh,
reaction, if
okay.
we decrease the temperature, that's gonna favor what?
The exothermic.
The exothermic, which is the other side.
I think so.
Yes, that's correct. Decreasing temperature favors the exothermic, which is
Yeah.
this side, the sulfur or the reverse reaction. So that's why we say that in our reason.
This wasn't a tough one.
Yeah, this one was
If I get it
straightforward.
on Monday, we should get similar ones. Like easy stuff, basic.
Yeah. Okay, and the KC table, it will have like two things because the solid again doesn't go in, so it seems like it's gonna be a little bit easy. I don't know if maybe we can just do it quickly.
Yeah, we can do it. But sometimes, I don't know if it's me, but sometimes they give us the solid, then we have to use it when we draw the table, but not in our calculations.
Yeah, that's true. I'll explain where and how. Let me just make space. That's true. Let me just do this. Is it gonna work? Maybe not. Okay. So I wanna paste that question, then we can look at it. Okay, let me just paste it right here because if I move this now, it's gonna not work out very well. Okay. Then the question says, where is it? If the concentration of CS2 changes by X, write down an expression for the equilibrium constant Kc in terms of X. They say show all your workings, no simplification or solving for X is required. So we're not going to solve for x at the end, but we're just going to represent everything. So you go and draw the rice table. Let me just use a shape to help me. And that's, let's say maybe, okay, let me address where we need to include the C. We need to include the C if they give us the initial amount or the amount at equilibrium, only if it's going to help us to find the amount of something else using the ratios. That's the only time we need it.
Also, it gave us the initial number of moles of the solid.
Yeah. Or if they give us how much it changed, like if we used up maybe 2 grams,
Okay.
then that way we can use that to work out what amount of sulfur we actually used and what amount of CS2 we actually produced, stuff like that.
Okay,
Yeah.
I get it.
All right. But as we know, it's not gonna go into the Kc expression, so that's fine. Let me divide this table so that we can do our calculations. We'll check if we need C at the end, but I'll just assume, because I don't have any given information on C, I'm just not gonna have it. Yeah.
Yes, we don't need it.
Okay. So we have, okay, let me just draw all my deviations that I need. So we have initial moles, and then we have change. From change we have what
Equilibrium.
is at equilibrium, and then from there it's just gonna be dividing by volume to find the concentrations.
But yes.
Okay, so the reaction is sulfur and CS2. Then the ratios is 2:1. Maybe I can just include it on there. Just say ratios. And then there's initial. I'll just put I in moles. Then let's see, do we have any information on the initial?
Yes.
Okay,
The carbon disulfide is 1.
Okay, the carbon disulfide is 1.
Oh, at equilibrium. But yes.
Yes, it's actually,
I'm right.
wait, is it at equilibrium or is it initial?
I actually don't know.
Okay, so that
I
information
think
where they said 1 mole of CS2 is present in the container at equilibrium, it was right here. Okay, then the new statement just says the volume of the container is now doubled. Okay, first we know the volume is now 4 from 2. And
yes.
after a while, new equilibrium is established. How will the amount change? Explain the answer. If the concentration of CS2 changes by X. So this is now at equilibrium. They say that concentration will have to change. And we knew the concentration before. It was what? 0.5?
1. Oh, yeah.
0.5.
So we must. Yeah.
Why do they wait? I'm also getting like
I think
confused a little bit.
I think the 1 is our initial, because a new equilibrium will be established after doubling the temperature.
Oh yes, that is true. Yeah, the one mole is the initial because now there's gonna be a new equilibrium. Yeah, that part of new equilibrium. Okay, so let's do that. Initial is 1. Then
We can. Never mind.
I
Yeah.
think we need
Thank
to
you.
try to find the initial for sulfur, because we know it's not going to be 0. Why? Because we already produced, or it's a reactant that we had and it's not finished at equilibrium. How do we work out the initial moles of that?
Let me try and calculate something and see. Because now, this question, I thought it was simple.
It's too much, ne?
Yeah.
Because we also have, let's see, we also have carbon at equilibrium 1. I'm thinking if we can do the ratio to find that, will it work out?
It will be, if we use the ratios, it's over 0.5. I think.
Or 2.
With X. No, it's over 2.
Okay, let me just fill the table. This is change in moles, and this is quantity at equilibrium. So just say equilibrium moles. This is concentration at equilibrium. So square blocks at equilibrium in mole per decimeter cubed. Okay, and the question is, can we define any information on any of these steps?
I think so.
Yeah, let's try to
Already
do
we
that.
know what the 4x for our thing. Volume. Wait. Yeah. It's a good one.
Yeah. Doesn't look straightforward also to me. But I want to get
It's
like
not.
ideas.
It's not because they gave us information after they gave us information. So they gave us information after they added information from the information that they gave us. So let's write down the information. Initially, we had 1 mole.
Yes.
Then our volume, yeah, double. It was 4 sharp. Our Kc, it's 9.4. We get it. We
Yep.
get that part. Um, to get our change, ne? What do we do? Normally, when we get our change, it's no man. Because I think if we get our change for the product, it
Yeah.
will open the door. Everything.
Okay, let me go back to, wait. Oh, I did that question a little bit up there. When we find the Kc, or the concentration of, we found the concentration of what again? It was the concentration of sulfur. So can't we use that to actually find the number of moles of sulfur, since we know the volume? This was the first equilibrium, remember? So
Oh, can we have information?
yeah, I can definitely use that to find the volume at equilibrium, at the first equilibrium for sulfur. So that's going to be,
Also, 0.23 times 2 because it was
yes,
before it doubled.
yes.
Okay, it makes sense.
Okay,
Yeah.
0.23 into 2. At the first equilibrium, the volume was 2. So, okay. So we get what? 0.46 moles.
Yes.
So 0.46 moles. And then
And then we have to find our change.
can go to our change block. Yeah. But here's some information that they gave. They say if the concentration of CS2 changes by X, and this changes is in capital letters.
Mm-hmm.
So concentration is equal to number of moles over volume, and the concentration changes by X. So it means we have X equal to number of moles times volume. Therefore, the volume is for the new equilibrium. Then this means the number of moles will be 4x.
Wait, constant. So it's C equals to N over V, Yankee.
Yes.
O X N O, okay, over 4, because it was after it double. Okay, yeah, I agree.
Yes. All right. So changes the moles themselves are 4x. Then we can work out the moles of the S side. Just gonna be times the ratio. So this makes it 8x. Then from here we found the key, because now it's just gonna be initial for the reactant. Wait, let me erase this.
Minus the G.
Okay, I feel like, okay, let me just
No,
say,
what am I
let me say this. This question was like hard, if I'm being honest, because also you have to consider the fact that
Yeah.
the reverse was favored. So it's the reverse that should get a positive. This one should be a negative. So 0.46 plus 8x, because we're producing sulfur. And this side 1 minus 4x. Do you agree, or do you have any question? What do you think, everyone else? So remember that doubling the volume.
Hey, you're breaking.
Oh, I'm breaking.
I think it's my Wi-Fi.
Oh, it could be your side. All right, that's fine. Just to point out what I was saying, doubling the volume favor the reverse. That's why we have a plus now on the sulfur. So sulfur kind of becomes our product for this time. So that's why we
Sir,
plus. Yes? Can you hear me? Okay, I think later we're having problems with the Wi-Fi. Everyone else can hear me. Can I see the show? Yes, later we can go ahead if you have a question.
yeah, I didn't hear anything. The 4x, I only had the last part when you were writing 0.48 plus 8x, but I understand that part.
Okay,
I
yeah.
don't know which thing. Were you
Okay.
on the concentration?
Yeah, I was just explaining why we have a plus on the reactant instead of on the product. But you understand that now, ne?
Oh, yes.
Okay.
So we can proceed.
Yeah, the last block is just to divide by the volume. This volume is 4.
Which is
Yes. Then that is
Then
it.
from
We just need to express Kc, right? So we say Kc is the concentration of whatever we have on the product side divided by whatever we have on the reacted side, and this is equal to, the sulfur has a 2, so we have to include that squared. Then on the product side we have 1 minus 4x over 4, everything over 4. Wait, let me just fix that. So 1 minus 4x, everything over 4, divided by, this quantity should be squared, 0.46 minus 8x over 4 all squared. And this is the final answer. Yeah, this one was like crazy. I don't believe it's 5 marks. this one was
and
hard, I'll
that
admit.
it was also if you didn't double your volume, if you didn't refer to your previous answer.
If you
Yeah.
didn't do the concentration changes by X thing,
Yeah.
yeah, nah. Hey, this one was like out there. Yo,
Yeah.
okay, but anyways, we got to the thing, so I guess now it's been like how many, 3 hours minus.
Yeah, a full exam.
Yeah, we did enough. We did enough.
That's the important ones. The
Yeah,
other ones simple.
yeah.
Just
Do you need the recording of this, or is it fine if I don't upload?
no, it's fine if you don't upload because I understand. Until
Yeah,
I was participating, so
sure.
now I
Okay, that's good. Yeah, if there's no other question, then you can be free to leave, Letabo,
okay.
and good
Thank you.
luck. Yeah.
Yeah. Don't worry, chemistry, I'm gonna nail it. I'm gonna nail it. Ke kwa theory paper one in Bethel.
Yeah, I hope you show them.
Yes. Bye.
Sharp. Okay, yeah, that was a lot that we did. So actually I'm gonna stop the recording that is running right now and see if we need to do another thing.